So we've looked at three methods for factoring trinomials. Which one is best really depends on you. Trial and error, the advantages of that technique is that you end up working with the smaller numbers because you only work with the numbers in the trinomial. You don't multiply anything together. It can be quick when you find the right combination on the first or second try. The disadvantage is that guessing is not something that everybody likes to do. So some people are okay with it, some people not. The AC method will get you the same answer. Two methods. If you like showing box, if you like that visual style, the AC method is great. It doesn't involve any guessing, and you can kind of diagram what's going on. It's also a great method if your polynomial's prime, because you don't spend a whole lot of time guessing when something won't factor correctly. So one thing I will often even tell the people who use the trial and error method is that if you aren't getting the right combination and you start to suspect it's prime, use an AC method to confirm whether the polynomial is prime, because that will just confirm it right away without you having to continue to take guesses. A disadvantage of the AC method is you have to work with larger numbers because you have to multiply A and C together and then factor that larger number. That is not great for people who have weaker multiplication or division skills. Now, if you have weaker multiplication and division skills, you can work on that. Factoring is going to make you get better at multiplication and division, but you are making it a little bit harder for yourself if you use the AC method because you have larger numbers. Whatever method you choose, you really have to just practice it a whole bunch, whether it's trial and error, the AC box method, or the AC shortcut method. Practice, practice, practice. It's going to be important that you can factor these types of trinomials not only later in this chapter when we solve quadratic equations, but when we look at rational expressions later in the term and rational equations later in the term, and including going on to pre-calculus, college algebra, trig, also calculus. All of those classes are going to ask that you factor at some point. So pause the video, try these 6 problems out, and then of course do lots of homework, but you can unpause when you've done these 5 or 6 and we will look at them together. All right, so let's look at these together. I'm going to use the AC method because I've done a lot of examples with trial and error already in earlier videos. So 15 is the A times positive 6 is the C, so that gives me 90. I'm going to factor 90, looking for something that adds up to negative 19. So 90 is positive, negative, and 19 is negative, so I'm going to use 2 negatives. Negative 1 and 90, negative 2 and negative 45, and you can keep going in order here, but you may already see that negative 9 and negative 10, if I kept going eventually I'd get here, do add up to negative 19. So I'm just going to grab those right away. We're going to then create the box, and in the box I'm going to use 15x squared, my first position from the trinomial, and then the positive 6, which is the last term from the trinomial. Then I'll use these 2 factors I found in the other positions with x, negative 9x, negative 10x. Then I factor to the left. 15x squared, negative 10x have a 5x in common. Take that out. Up above, 15x squared divided by 5x is 3x. Negative 10x divided by 5x is negative 2. Make sure you use that sign. Now, negative 9x and 6 have a 3 in common, but because the 9x is a negative, take out a negative 3. So negative 9x divided by negative 3 is positive 3x, so that checks. And then the 6 divided by negative 3 is a negative 2, that checks. So my answer in this factoring problem would be on the left and the above the box. So I would have 5x minus 3 times 3x minus 2. That would be my factorization. You can multiply that out to check. 5x times 3x is 15x squared. Outside is negative 10x. Inside is negative 9x. And last terms give me positive 6. These middle terms do add up to negative 19x, which gives me exactly what I started with. All right, our next example, the A is 10, the C is negative 8, so that gives me an AC of negative 80. So I'm going to factor that looking for two pair of factors that add up to 17. So negative 1 and 80, negative 2 and 40, If you don't see it right away, just keep going in order. -3 won't go into 80, -4 will 20 times, -5 will go in, let's see, 16 times, -6 won't go in, -7 won't go in, -8 will go in 10 times, 9 won't go in. So these are all of our factors because we've looped back around. When you add these up, none of them are going to add up to 17 or even -17. The closest I get is 16. Everything is not what we had here. Here's an example of the AC method telling you without having to do any guessing that this is not going to factor. Because I don't get the correct sum, the correct value for the middle term, that means that this trinomial doesn't factor. So this would be a prime trinomial. If you had done the trial and error method here, there's a lot of factors of 10, or at least 2 pairs of factors of 10. There's 2 pairs of factors of -8, and that would be a lot of options to try. When you use the AC method, you can see right away it's prime. All right, let's do one more with the box method, and then we'll go to the AC shortcut method. 3x squared plus 11xy plus 6y squared. A is 3, C is 6, so that's an 18. If I factor 18, 1 and 18, 2 and 9, and I'm not even going to go any further because 2 and 9 give me that middle term of 11. So I'm going to take and create a box using, again, the first term in the first upper left location of the box. The last term goes in the lower right part of the box. And notice we have 2 variables in this example. So when I put the 2 and the 9 in, I need to use 2xy and 9xy in this position. So make sure this 2 and the 9, because I have 2 variables, both have an xy with them. All right, now we factor to the left with both the first row and the second row. 3x squared and 9xy have a 3x in common. When you take that out up to the top, 3x squared divided by 3x is x, and 9xy divided by 3x is 3y. And that was a positive, so we'll make that a plus. 2xy and 6y squared on the bottom row here have a 2 and a y in common. And then when we factor that out, 2xy divided by 2y does come out to the x, so that checks. And 6y squared divided by 2y comes out to 3y squared, so that checks. So my answer here is on the left and up above the box. So I will use my binomials as 3x plus 2y times x plus 3y. Last step to see that that's the correct result. Factor or multiply to check. 3x times 3x is 3x squared. Outside is positive 9xy. Inside is positive 2xy. And last terms are positive 6y squared. These 2 middle terms do add up to 11xy, so we are good. That checks. In these last 3 examples, I will use the AC method, but I'll use the fraction or the shortcut method instead of the box for those people who have wanted to use the fraction method. If you use the box method or the trial and error method, that's fine. Just check your final answer. So again, this next problem has 2 variables, the x squared and the y squared, so keep in mind you are going to use both x and y in your final result. Let's go ahead and do the AC. A is 6. C is -5, so we're going to use -30. When I factor -30, I'm going to factor looking for a -7. So -1 and 30, -2 and 15, -3 and 10. That looks good. That's going to add up to a 7. I want a -7, so just change signs. So I'm going to use a positive 3 and a -10 to get a -7. Now, instead of creating a box, we take the 3 and the 10 and we divide, keeping the negative in the top, we divide by A, which is 6 in this example. Then we simplify. 3 over 6 is 1/2. -10 over 6 is -5 over 3, taking a 2 out in that second one. These will be the numbers we use in our answer with our binomials. So setting up our parentheses, 1/2 is going to go into the first location. Remember, the 2 comes first, the denominator comes first. 2x minus, or plus, because that's a positive 1, plus 1 And then don't forget there's two variables, so we use a y here. The second fraction goes into the second factorization. So denominator first, 3x, and then the minus 5, don't forget the second variable y. Now, we've mentioned that you don't need a 1, so this 1y can just be y. That's what we would normally write. And to check that, we FOIL out just like we've done in all the other problems. 2x times 3x is 6x squared. Outside terms are negative 10xy. Inside terms are positive 3xy. And the last terms are negative 5y squared. We have the first and the last term, just check the middle. Negative 10 plus 3 is negative 7xy, so that checks. All right, last two examples. There is one thing you should always look for. I wanted to do some without having to worry about this, but in general, always look for a common factor. What we have in this first example, 15x squared plus 18x squared plus 3x is a common factor of not only 3 but x. There's an x in every term. So the first step is to take that 3x out. It's going to make the problem much easier. So 15x cubed divided by 3x is 5x squared. Do the same thing to the next term. We're going to get 6x. And anything divided by itself is 1. So don't forget, that doesn't just go away. 3x divided by 3x is 1. Now we're going to use the AC method, not with the original problem, but with what's left over. So 5 times 1, A is 5, C is 1. When we factor a 5, there's only one way to factor it, and luckily that adds up to the 6, so this can continue to be factored. Don't forget this is the AC method, so we take those numbers and we divide by the leading term, or A, and we simplify. Now, 1/5 isn't going to simplify. So since it doesn't simplify, I'm going to leave it as is, and that will become my first factor. So the 5 goes first because it's in the denominator, plus 1. And then my second factor will come from simplifying this other fraction. 5 over 5 is 1, but remember we want it written as a fraction, so 5 over 5 is 1 over 1. We use those values in the second value because you need two values, one for the denominator, one for the numerator. So 1x plus 1. Remember we don't need the 1 in front of the x, so most people would just write that as x plus 1. And then to check this final result, always multiply through the 3x to the first factorization first. So 3x times 5x is 15x squared. 3x times 1 is 3x. Then take that and FOIL it to x plus 1. So if we do that, we get 15x squared plus 15x plus 3x. 15x squared plus 3x squared plus 3x, and those two middle terms do add up to the 18x squared, so that checks even though I'm out of room. All right, last problem, 4y squared minus 18y minus 10. There is a common 2 there. Take that out, 2y squared minus 9y minus 5. Now our AC would be with the 2 and the 5, negative 5, so that would be negative 10. Factoring that negative 1 and 10 would give me a positive 9, so use positive 1 and negative 10. So I'm going to take each of those, divide by A. My first fraction doesn't simplify, so that becomes my first binomial, 2y plus 1. And then my second one does simplify to negative 5 over 1. So I'm going to use 1y minus 5. So that should be my result to check. First multiply the 2 to the first binomial. So 4y, oops, I didn't change colors there, 4y plus 2 times 1y minus 5. So we have 4y times 1y is 4y squared when we FOIL it out. Outside terms would be negative 20y. Inside terms will be positive 2y. Last terms would be negative 10. I'm out of room, but if we look at those two middle terms, negative 20y plus 2y do give me the negative 18y. So that means that this does check as my answer. All right, so there's some extra practice with factoring. Now practice in your homework.